Right now, generative AI is hardwiring itself into the core of enterprise DevOps and security workflows at a pace we've rarely seen. The pitch is incredibly compelling. Teams are promised continuous deployment pipelines that run themselves, automated threat detection that flags anomalies instantly, and massive cost savings across the board. But the exact same tools enabling these efficiencies are also in the hands of attackers. GenAI is democratizing cybercrime, giving anyone the ability to generate automated, highly targeted malware and convincing deepfakes at scale. This puts technology leaders in a difficult position. Adopting AI to stay competitive often means embedding complex logic flaws and security misconfigurations into the software before they are ever detected. This matrix breaks down the trade-off. The left shows the promise of speed and operational efficiency. The right shows the expanding attack surface. Look at the bottom row. A severe talent deficit. Engineers using AI without deep security knowledge actively make the network more fragile. Securing an AI-augmented infrastructure is limited by a critical shortage of human governance, regardless of how many defensive software tools you deploy. This quadrant chart maps AI tools. The horizontal axis represents AI autonomy, while the vertical shows the security overhead required. Up here, we plot generative coding assistants. They don't have high autonomy, but require surprisingly heavy governance. While these assistants excel at eliminating developer toil, data shows they choose an insecure coding method up to 45% of the time. Because of that error rate, application security teams are suddenly overwhelmed. They have to manually review a massive new influx of AI-generated code to prevent those vulnerabilities from reaching production. Now look at the far right of the chart. As we plot fully autonomous AI agents, the required security overhead skyrockets. These agents operate differently. They are granted direct access to execute actions across external tools, enterprise APIs, and internal databases. This creates a critical new vulnerability known as malicious agent tool calls. If an agent is manipulated, it can independently execute harmful code or exfiltrate sensitive data. Attackers achieve this using prompt injection. By hiding deceptive instructions in seemingly benign data, they can alter the agent's logic entirely, turning a helpful internal optimization tool into a highly destructive active insider threat. Automation in the CI/CD pipeline creates more work for security teams, requiring a higher density of experts to manage the increased volume of system signals. To combat these threats, organizations are deploying AI-powered security tools, like network detection and response, or AI-driven SIEMs, to fight back at machine speed. These defenses provide immediate relief. They drastically lower the mean time to respond to an incident and help reduce the severe alert fatigue burning out SOC analysts. But threat actors have developed a sophisticated new counter-tactic, corrupting these defensive systems from the inside out, completely undermining their reliability. This is called data poisoning. Adversaries intentionally inject misleading examples into the model's training data, teaching the defensive AI to ignore specific malicious behaviors. When security teams rely entirely on automated defenses and assume the AI is infallible, they create a massive blind spot for attackers to exploit. To counteract this adversarial drift, operations teams must run continuous red team exercises and manually update their models to recognize the latest evasion techniques. Defensive AI operates as an endless treadmill, not a permanent shield. It requires constant, highly skilled human oversight to stay effective against evolving threats. This brings us to the reality of the talent market. Simply opening up headcount for AI engineers is failing to solve the security crisis. The market is flooded with recent bootcamp graduates. Most are trained only to write prompts for third-party SaaS interfaces, rather than understanding the underlying architecture of the models themselves. Institutions recognize the gap. Top-tier academic and policy centers are actively trying to retrain existing cybersecurity leadership to handle the complex realities of AI models, pushing a return to core engineering fundamentals. There is a vast difference between basic tool application and the creative problem-solving required to detect hidden model bias or evaluate a vendor's governance framework. To build true national talent pipelines, real-world government initiatives are stepping in. They are training engineers from the ground up on open-source foundation models, data cleaning, and strict model evaluation. Without this deep expertise in-house, companies fall victim to shadow AI. Untrained staff start using unsanctioned, public generative tools for their daily enterprise work. When those employees rely exclusively on black box third-party AI products, they compound the threat of exposing proprietary code and sensitive data back to the vendor. Enterprise security depends on engineers who can interrogate and build sovereign architectures from the ground up. This tiered readiness checklist provides a strategic framework to help you determine a safe level of AI adoption based on your internal governance capacity. Let's start with the lowest tier, the tool-centric approach. For any serious enterprise, this level should be avoided completely. Organizations operating here lack the IT infrastructure to monitor what their employees are inputting into public models, leaving them highly exposed to shadow AI and severe data leaks. The middle column, balanced governance, is the practical target for most mid-market companies. It serves organizations that need the speed of AI but are working with limited security budgets. This tier has strict rules. You must enforce rigid vendor service level agreements, completely ban autonomous agentic tools, and align your defenses with established standards like the OWASP Top 10 for LLMs. Most importantly, this tier requires keeping a human in the loop. Every single line of AI-generated code must be manually reviewed. Finally, we look at the AI sovereign tier. This is the mandatory standard for large enterprises, governments, and financial sectors handling highly sensitive data. Operating here means abandoning black box SaaS tools. Instead, these organizations invest heavily in upskilling their talent to build, fine-tune, and secure open-source foundational models internally, keeping their data entirely private. Safely scaling AI requires a commitment to building robust human governance over the search for a quick software fix.